Hi all, here's another video for you. So this one is about making salts from carboxylic acid. So first thing you need to know is the definition of a salt. It's in the back of the textbook in the glossary. But basically it's when you have an acid and the hydrogen of the acid is replaced by a positive metal. So here's your hydrogen, it gets replaced, it comes off, there it is. And instead you have your positive metal on. So there's your metal. Right, okay, so when you did these in your ILB, I noticed some of you weren't quite balancing them. It's fine if you have the group 1 metal, so sodium, potassium, lithium, because this acid here, the carboxylic acid, it loses its hydrogen and becomes a single negative on the oxygen. So when you have a single negative on this, what we call an ethanoate salt, this was a propanoate salt, then you end up with single negative here and your metal, sodium, potassium, whatever, positive, and that balances out fine. However, if you use a group 2 metal or a transition metal with a 2+ charge, you normally get the group 2 ones there, then of course the same thing happens. Your hydrogen is lost, you've got a single negative charge on that, and you can see that negative charge there, it's on the single bonded O, not the double bond O. And what happens is, because that's got a single negative charge and your metal has a double positive, then you need 2 of these in order to balance those charges out. So what you can see I've done is I've put square brackets, not square brackets, curly brackets around the salt bit, put a 2 here so that balances out. Now you can see that's not balanced because I've got the magnesiums are fine, the 2 hydrogens are coming off from here, so I need a 2 there because there's 2 of those, and of course the 2 hydrogens, which is this one here, go to make diatomic hydrogen. Also, now here's another example I've done it, that one displayed so you can see what's happening, and here we have a skeletal. So this time I've put a double-ended one, so I've made it a bit trickier now to get you thinking and to get those application skills going. So this one is a double-ended carboxylic acid. We've got the group 2 metal, so you can see the hydrogen comes off, it's that same hydrogen that's on here, the same one that makes the hydrogen bonds in your hydrogen bonding solubility diagrams, and you can see that comes off and the one on this side comes off. You've got single, oh sorry, I've taken off the wrong one, let me just change that, naughty Paula. There we go. So the hydrogen comes off, you're left with a negative charge. This time you've got negative, negative, so 2 negatives. That balances out with that. So if it's a double-ended one, you don't need the brackets and the 2. If you still want to put brackets in to show that the 2 negatives, although they're at either end, they still cancel out with that one there. You can put brackets in if you want. And of course the 2 hydrogens go to make this diatomic hydrogen that gets given off. So metal plus acid makes salt and hydrogen as normal. Hope that helps, guys. Thanks.